I've given you a brief overview of the conservation of momentum, as well as real life scenarios where it could be applied, we're going to go through a problem that you might see in a book. So two balls are traveling towards each other. Ball A has a mass of 10 kilograms, kg per kilograms, and a velocity of 5 meters per second. Ball B has a mass of 5 kilograms and also has a velocity of 5 meters per second. So they're traveling at the same speed, that is at different masses. After the collision, ball A has a velocity of only 3 meters per second. What is the velocity of ball B after the impact? Now, to solve this problem with any physics problem, you're going to be given a whole bunch of numbers. And your key is to identify these numbers. Now in the problem, as you saw, I highlighted some of the important numbers. In your textbook, it won't be highlighted for you, so you have to find them. So I'm going to go through this, and it's also good to draw pictures. Pictures are always great with physics. You cannot do physics unless you draw pictures, because you have to be able to visualize what's going on. So, ball A has a mass of 10 kilograms. Right here it's traveling at 5 meters per second. Ball B has a mass of 5 kilograms, traveling also 5 meters per second towards each other. After the impact, ball A has a mass of 10 kilograms and is traveling 3 meters per second to the left. After the impact, ball B has a mass of 5 kilograms, which is the same, of course, and they want you to find how fast they're traveling in opposite directions, which correlates to VB2. So in this equation, you're given all these variables except for one. Anytime you're given all your variables except for one, you can always solve for the equation. Sometimes if you're missing 2 variables, you can solve for the equation as well, but we're not going to go into that. So step 1, after you draw your picture, label everything, figure out what you need to solve for and what the problem is giving you, you actually start solving. So we go right here, M1 times V1, 10 times 5, plus M2 times V2. When you add all this together, in the end, I skip some steps to kind of speed it up. You're going to get 75 kilograms per meter per second. Now when you do this, make sure you always have to have your units. Keep your units, because your units will always cancel out and let you know if you got the right answer or not. On this side, you have 10 kilograms of ball A traveling at 3 meters per second, as well as 5 kilograms for ball B. You have your unknown right here, which is VB2. So you simplify that down, you get 30 kilograms per meter per second plus 5 kilograms times VB2. So then you move on to your next step, which is step 3. You are going to subtract, just like you're going to do it, just solve it just like any other equation. So you subtract 30 from here. Subtract 30, keep in mind they have the same units. I'm not writing them, but remember they have the same units. So you're going to get 45, 75 minus 30 is going to give you 45 kilograms per meters per second. And that's going to leave you only with 5 kilograms times VB2 on the other side. So this is what you get. Now of course we all know how to solve equations. You have your unknown, but you pretend like this is an x in a regular equation. So you divide by 5 kilograms. Both sides. Now, 45 divided by 5, of course, is going to be 9. And your kilograms are going to cancel. This kilogram is in the numerator, this kilogram is in the denominator. They cancel out. So that leaves you with meters per second. And if you're looking for something in physics, always check your units. If I'm looking for velocity and my final answer comes out in kilograms, I know I did something wrong. That's why units are important. My answer came out in meters per second, so I know that that is the correct answer, or at least I have the right units in my answer. If I did mess up, it was something dealing with numbers. And so your final answer is going to be that the velocity of ball 2 after the impact is traveling at 9 meters per second. And this makes sense, because you have a big ball, you have a little ball. They're going towards each other at the exact same speed. When the little ball hits the big ball, it's not going to push the big ball far. The big ball, on the other hand, has more mass and more momentum, so it's going to push the little ball further, making it go faster. Which is why ball B travels faster away from the impact than ball A, which is going to travel at 3 meters per second. Once again, this is an application of physics, and once you see numbers like this, you'll be able to understand that it's all common sense. And once you just think about it in depth, it all makes sense to you. Alright, once again, my name is Justin Henderson. This has been the Conservation Momentum Theory. I hope you've enjoyed it. I hope you take something from it. I hope this maybe inspires you to try physics. It will be hard, but it is fun and it is rewarding. Have a good one.